In this pivot lab, you're going to investigate the gravitational potential energy of a system as a function of time. So we're going to need to do a derivation. We'll start out with the equation for gravitational potential energy. M and G are constants with time, and so we don't have to substitute for those, but the height does vary with time, so we're going to have to substitute in an equation that describes the height as a function of time. Here is the equation for position as a function of time, and we're just going to insert variables that reflect the situation a little bit better. I'm going to substitute h for height for the position. The initial position of the ball is going to start from 0. The next term doesn't change. And the next term, I'm going to substitute in negative g for the acceleration because the ball is in free fall. The negative sign indicates that down is the negative direction. And on the next line, I'm just going to tidy that up a little bit. And now we can insert it in for h into our original equation for gravitational potential energy. You should notice here that we have a t squared, so that means that we should end up with a quadratic equation. And when we have a quadratic equation, it's very common to investigate the parameters or the constants of the variables. So the next step in the algebra, we're going to distribute that mg to the two terms inside of the parentheses. Here is the first term and the second term. And we can just tidy that up a little bit, and we have our equation for gravitational potential energy as a function of time. Now, when we analyze the parameters or the constants in the equation, the coefficient of t squared is what we're going to refer to as a. Notice everything in there is a constant. Here is the coefficient of the first order variable, which we're going to refer to as b, and we need to predict what the value of c is, so we can just add 0, and so c is going to be 0.